All right, you do not need your computers open, so please shut them. A kite. So, a kite y'all hear about flying, but a kite is actually a shape, not just something you play with outside. What is special about a kite are some specific properties that it has. It is a quadrilateral, so how many sides does it have? 4 sides. What's special about a kite is it's not a parallelogram. These sides, these opposite sides are not parallel. But 2 pairs of adjacent sides are congruent. Please write congruent. Which means whatever this side is, one of the sides, not both of them, but one of the sides right next to it will be the same. And whatever this side is, the other side next to it will be the same. So, some properties of kites. 2 pairs of consecutive sides are congruent. What do you notice about my diagonals here? Say, yeah, what do you notice about these diagonals right here? Okay, so we're going to talk about bisects in just a second, but what do you notice about the angle right here? It's a right angle. It is 90 degrees in the middle of a kite, always. So the diagonals are, I'm going to do the perpendicular symbol, or 90 degrees if you need to remind yourself. Now, you mentioned the word bisects. What does bisects mean? Cut in half. Now, right here is we call this the long diagonal, and we call this the short diagonal. Do y'all agree the diagonals are not the same in a kite? Okay, the long diagonal. Is this long diagonal cut down the middle? No. Do you agree that is way smaller than that right there? So the long diagonal is not cut down the middle. However, is the short diagonal cut down the middle? Yeah. Yes. So I'm going to actually do 1, 2, 3 tick marks right here. 1, 2, 3 tick marks right there. The long diagonal bisects the short diagonal, meaning the short diagonal is cut in half. And that will work every single time. But not only does the long diagonal bisect the short diagonal, what else does the long diagonal bisect? The whole kite. Do y'all agree that if I were to draw this line right here, the top is the exact same as the bottom? This is a line of symmetry. The long diagonal is symmetrical. Because of that, it also bisects these angles. That angle is the same as that one. This angle is the same as this one. And then what is this angle the same as? The one on the bottom. So the long diagonal bisects opposite angles. And I want you to add at the bottom 2 congruent, triangles. Let me write above it, long diagonal makes. The long diagonal makes 2 congruent triangles. It is, y'all agree if you were to cut it at the long diagonal, you have 2 congruent triangles. That is what a kite is. So we're going to do some practice problems together, and then I have a worksheet for y'all to go off on your own. Okay? So open up your notes, please. All right, 6 examples. Please write down everything I'm writing down. You are going to be able to use these notes on your assessment. You're going to want to use these notes on your assessment. So please, if I'm writing it down, you are too. Anywhere on this paper. QS. If QS, that's this whole thing, is 10, what is TS? 5. What is QT? No, QT. Do y'all agree if the whole thing is 10, it's 5 and 5? Yeah. Because it's the short diagonal. Only the short diagonal can be cut in half like that. Okay? If angle R is 80, this right here is 80 degrees, and angle S is 110, what is angle Q? Why is Q 110 as well? Yeah, it's a cross. They're the same on the kite. So Q is 110. Remember, that long diagonal cuts this in half, so they're the same. How do I find angle P right here? It's not the same. So these two angles right here, you see how this has one arch and those have two? They are not going to be the same on a kite. But a kite is a what? What does a quadrilateral add up to? That's a triangle. 360 degrees. So, if I know these three right here, can I figure out the fourth one?
Yeah.
So let's add them together and subtract from 360. So 110 plus 110 plus 80 is 300. And then subtract that from 360, what do I get? Angle P is 60 degrees. What questions can I answer? Are we okay with that? All right, next one, I'm going to fill out all this stuff. SQ is 12. If this whole thing is 12, what do I know? 6 and 6. PT is 12. TR is 4. Ooh. Find QPT. QPT, we're looking at that middle letter. And I'm going to start at Q, go to P, go to T. QPT is this right here. Oh, man. We have not seen this in a hot minute. Everybody look up, please.
Well, you know you have a 90 degree.
I do have a 90-degree angle right here. And I want to know what is this angle right here. How do I figure out an angle
You label yours.
if I have no other angles? I label my C. Do I have the hypotenuse? So I'm going to do SOHCAHTOA. Which one am I going to do? TOA. We have not done SOHCAHTOA in a whole unit, right? We're going to be using SOHCAHTOA today and tomorrow and on the assessment. So let's remind ourselves. If I don't have the hypotenuse, I'm going to do TOA. So I'm going to do the tangent. Well, hold on. The tangent of, what's my angle?
90.
This angle?
Or this X.
X. We don't know what it is. So I'm going to put X equals, what is opposite of this angle? 6. What is adjacent to this angle? 12. Again, I know it's been a hot minute. That's why we're doing this together. As a reminder, what does your calculator need to be in order to degree mode. So please, when you're doing this, make sure you're in degree mode. Last unit, it didn't matter because we didn't do SOHCAHTOA. Degree mode only matters if you do SOHCAHTOA. When I'm looking for the angle, what do I do? How do I get x by itself?
Oh, you switched it back?
Inverse. I'm gonna inverse. I know it's been a minute. We gotta remind ourselves. So in the calculator, I am gonna do the tan inverse of 6 over 12, and I get 26.6 degrees. The next question wants to know about QRT. So we're looking at that middle letter, Q to R to T. That's this angle right here.
You just do the same thing.
We're going to do the same thing with different numbers. So I'm going to draw my 90 degrees. Again, that's my hypotenuse. Do I have the hypotenuse here?
No.
No. So I'm still going to do tangent. The tangent of x, this one. What is my opposite here? What is my adjacent? And if you're like Miss Olivars, what? We'll do some practice with this. How do I get x by itself when it's the angle? Inverse. You are writing this down. Everything I have written down, I want you to write down. Again, this is for your notes for your assessment. And so this time I'm going to do 6 over 4. What is my angle? 56.3 degrees. Questions? All right, this next one tells me RT is 3. QS is 8. If QS is 8, what do I know?
They're 4 and 4.
They are 4 and 4. And PQ is 10. If PQ is 10, what do I know? Everybody write this down with me. Ryan, you should not be on a computer right now. Y'all should not be on your computers. Now, it says find RS and the perimeter. Oh, fun. This is going to be fun. How do I find R? They're bringing up all the old stuff here. How do I find this RS right here?
You also do the 90 degrees.
I can do a 90 degree right here. And I can do my C. You are right. We are going to do Pythagorean theorem. If you have two sides and I want to find the other side, you do Pythagorean theorem. If you have two sides and I want to find an angle, you do SOHCAHTOA. So, I need to do Pythagorean theorem, which is C squared equals A squared plus B squared. C squared equals, which one do I want to be A and B? It doesn't matter. We'll do 3 squared plus B is, what do I do? I got to get rid of this squared, square root, and put that in the calculator. What is 3 squared plus 4 squared square rooted? It is 5. Hey, by the way, that's called a Pythagorean triple. If you have 3 and 4, your other one will always be 5. Your hypotenuse will always be 5. That is one of the rules of Pythagorean theorem. And you'll see 3, 4, 5 pop up a bunch. You don't have to do it if you see 3 and 4. You just know the answer is 5. Okay, well, if this is 5, what else do I know? The top is 5. So what is my perimeter? What's perimeter? Add all the sides. So I'm just going to add them. 10 plus 10 plus 5 plus 5. 30 is my answer. Questions? Again, if I wrote it down, I want you to write it down. All right, slide on over. We are almost done. QR is 2x minus 3. That's what that says. RS is 43. Well, if this is 43, what do I know? I know the top is also 43, so it equals 2x minus 3. So 2x minus 3 equals 43. I would like you to solve that. Go. Did you get x equals 23? Y'all get that? Mm-hmm. And then what's QR? We already said what QR is, but what is it? 43. We already know that. And we could plug in 23 right here just to double check and make sure we got it right. You would do 2 times 23 minus 3. We did get it right. Okay. STP. We're looking at that middle letter. S to T to P. What do we know about STP? It's 90 degrees. You're right, right angle, 90 degrees. So what do we know about 13x minus 1? What is 13x minus 1 going to equal? 90 degrees. All right, solve this one. Go. Oh, what did I do 89 for? Did y'all get 7? Yeah. You add 1 to get rid of the side chick, and then you divide, and you get 7. So x is 7, and that's my answer. Questions? As long as you know the diagonals are 90 degrees, that's good. Last but not least, if angle 1 is 23, and angle 2 is 55. Find the measures of everything else. What's the easiest one I should know? Okay, so what's S going to be? It's going to be the same thing. Remember, they're the same. And then I know the right angles in the middle. How can I find this angle right here?
Adding them all up.
Not all of them.
No, you do the thing with the C.
Do y'all? Nope, don't even need to do all that. Do y'all agree I have a triangle right here? When in doubt, draw a triangle. Find a triangle. I have a 90 and a 55. How do I find that one?
You add the 2 and subtract from the 90.
So I'm going to do 90 plus 55. That's 145. And then what am I going to do? Subtract from 180. Write that down. What I have written down, you are writing down. So 180 minus 145 is 35 degrees. If that is 35 degrees, what else do I know? Yep.
Wait, so those two are congruent, like the same?
Yeah, because remember, this line right here cuts this in half.
So 2 and 1 would be the same?
2 and 1 are not going to be the same. Only remember, the long diagonal cuts this in half, so those are going to be the same. But these two, not necessarily, no.
Okay.
If they were the same, this would be a rhombus. It wouldn't work out. Yeah. All right, how do I find this one right here?
Wouldn't it be the same thing? Just 35, 35?
The same thing, but with these numbers right here. Oh, no. These are not going to be the same as that. Nope, because look over here. Remember we got 80? Did we get 80 right there? No. So, draw a triangle right here. What numbers do I have for this triangle?
23, or 90 minus 23. No, plus. I'm sorry.
90 plus 23. And then subtract from 180. Is 67. And there we go. We have everything. Did we glue the flow chart in? We did it in this class. No? Okay. So, what I want you to do.
What is the flow chart?
Let me get that last one. You were with me the whole time, Marco. Get that last one.
Is this the flow chart?
No. It's the big one. I'm going to show you. Yes. Alright. The flow chart looks like, I hope I have one because I gave them out. Let's see. I should have one. Here we go. The flow chart looks like this.
Oh, yeah.
Yeah. So we forgot to glue that in. We're going to glue that in on 53. I'm going to glue that in like this. So this is page 52. On 53, I'm literally going to glue it in like this. 52 is parallelograms. That one should be glued in. Oh, this one right here. Okay, so I'm going to glue this in like this. Probably I'll fold it in the middle and I'm just going to glue the sides right here. And then the one we just did is page 54. Please glue it. Kites. Glue kites in on page 54. All right, and then I will give you a worksheet. It's only a half sheet to do for the rest of the class. And then you are done.
Wait, how do we glue it?
Just glue. I'm going to glue like the sides right here. Just glue this side right here. And that should be it. So you can. Alright. Let me stop my video. Thanks for watching.